Hello everybody, welcome to my channel Chemistry and Concern. Today I'm going to discuss about the carbon and its compound. It is the first chapter of organic chemistry, so basic but very important to study whole organic chemistry. So first of all, draw the main headings, that is carbon and its compound. Carbon and its compound. So I think you all know about the carbon can form 4 covalent bond with other elements. Actually, carbon can form the bond with hydrogen in organic compounds. So first of all, we have to know the meaning of hydrocarbon. First of all, hydrocarbon. Okay, everybody, draw your heading hydrocarbon. So you can figure out the definition of hydrocarbon from its name. Here is a combination of 2 elements. So hydro is stand for hydrogen and another element is carbon. So the combination of hydrogen and carbon gives hydrocarbons. So we can define this hydrocarbon in this way. The chemical 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 compounds formed by the combination of hydrogen and carbon are called hydrocarbon. So everybody, any chemical compound which is formed by the combination of hydrogen and carbon is called hydrocarbons. That is hydrogen plus carbon gives hydrocarbon. For example, series of alkane. So all the series of alkanes comes under the example of hydrocarbons. Like methane, number 1, methane, methane. Similarly, ethane, ethane, ethane. Similarly, propane or series of alkene. Example, ethene, ethene. Number 2, propene. Number 3, butane, etc. These chemical compounds are hydrocarbons and they are formed by the combination of hydrogen and carbon. But you can see here is a difference between these 2 hydrocarbon. So methane and ethane are 2 different hydrocarbons. In an alkane, there is a single bond between carbon and carbon, but in an alkene, there is double bond between carbon and carbon. So there are different type of hydrocarbons. So we can describe the types of hydrocarbon in its classification. So another heading is classification. So everybody wait for some time. So again draw your heading classification. So on the basis of the bond between carbon and carbon, there are two types of hydrocarbons. So you can write on the basis of bond between carbon and carbon, there are two types of hydrocarbon. So they are in number 1 saturated, SATURATED, saturated hydrocarbon, and in number 2 on, SATURATED, unsaturated hydrocarbon, unsaturated hydrocarbons. Okay, here is hydrocarbons, you can write yourself, saturated and unsaturated hydrocarbon. These two are different type of hydrocarbons. In saturated hydrocarbons there is a single bond between carbon and carbon. So the another heading, draw your heading another. So here is saturated hydrocarbon. So saturated hydrocarbons. So actually what is mean by saturated hydrocarbons? So in the saturated hydrocarbons there is a single bond between carbon and carbon. Those hydrocarbon in which carbon and carbon are bonded together by means of single bond, are called saturated hydrocarbon. So everybody, those hydrocarbon in which carbon and carbons are bonded together by a single bond are called saturated hydrocarbons. You can say the single bond is also called sigma bond. For example, you can take the series of alkane. All the series of alkanes comes under saturated hydrocarbons. So alkane, ALKANE, all alkanes comes under saturated hydrocarbons. So general formula of alkane is CnH2n plus 2. This is the general formula of alkane. So wait for some time, I will write here so you can see clearly. So I'm gonna show some very interesting examples of saturated hydrocarbons from methane. So let's see in number 1, methane, METHANE, methane. So the general formula of methane is CnH2n plus 2. So where n be the number of carbon atom. So you can write here C1 for methane, meth, there is a single carbon atoms, and H 2 into 1 plus 2, how much? C 2 1 are 2 plus 2, CH4. CH4 is the molecular formula of methane. And you can do this structure, 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 okay? Structure of methane. See here, carbon and hydrogen are bonded together by single bond like this. This is the structure of methane. Similarly, let's see in the ethane. ETHANE, ethane. General formula of ethane is also CnH2n plus 2, C2 for ethane, and the number of hydrogen is 2 into 2 plus 2, how much? C2H6. C2H6 is the molecular formula of ethane. So you can write here structure, STRUCTURE, structure. Carbon and carbon. So in the saturated hydrocarbon there is single bond between carbon and carbon. So you can draw like this, and all the bonds are bonded with hydrogen atom. So this bond is a covalent bond, and this bond is formed by the sharing of these two carbon, and each carbon should have 4 covalent bond. So you can count here 1 2 3 4 for this one, 1 2 3 4, the structure of ethane. Similarly you can do yourself for the propane, but I'm going to show you another one, butane, BUTANE, butane. So general formula CnH2n plus 2. For the butane there is a 4 carbon C4, 2 into 4 plus 2, how much? C4, 4 2 ja 8 plus 2, C4H10. This is the molecular formula of butane. For the structure, let's see here, structure, STRUCTURE, structure. 1 2 3 4 carbon atoms, and all the carbon atoms are bonded by single bond like this. 1 2 3 4, 1 2 3 4, 1 2 3 4. Here 1 hydrogen, 2 3 4 5 6 7 8 9 10, C4H10. So this is the structure of butane, and you can see here is a single bond, or you can say the sigma bond, all the sigma bond, and there is a single bond, means it is an example of saturated hydrocarbons, and all the series of alkanes comes under saturated hydrocarbons. So everybody, another one. Let's see in unsaturated hydrocarbons. Do number 2 here, on SATURATED, unsaturated hydrocarbon, unsaturated hydrocarbons. Those hydrocarbon in which, those hydrocarbon in which carbon and carbon are bonded by means of double or triple bond, are are called on SATURATD unsaturated hydrocarbon. So those hydrocarbons in which carbon and carbon are bonded by means of double or triple bonds are called unsaturated hydrocarbons. So there should be a double or triple bond between any two carbon in their structure. So let's see in example, series of alkene, ALKENE alkenes. All the series of alkenes comes under the examples of unsaturated hydrocarbons. Let's start from ethene, ETHENE, ethene. So general formula of alkene is CnH2n, just only CnH2n. So you can write here for the eth, there is a 2 carbon atom, 2 into 2, how much? C2H4, okay, C2H4. So for the structure, STRUCTURE. So everybody, let's see in the structure, carbon, there should be a double bond with, and for this carbon atom, 1. So here is hydrogen atom, here is also hydrogen, here is a hydrogen atoms, and these 2 carbon atoms are bonded to each other by double bonds. Similarly, in number 2, let's see propene, okay, propene. So general formula same way, general formula CnH2n. In propene there is 3 carbon atom, 2 into 3, how much? C3H6. C3H6 is the molecular formula of propene. So structure STRUCTURE. Let's see in structure, 1, 2, 3 carbon atoms, and you can draw double bond between any 2 carbon atoms and do like this for the bond, 1, 2, 3, 1, 2, 3, 4 for this carbon atom. Similarly 1, 2, 3, 4 carbon atom, hydrogen 1, 2, 3, 4, 5, 6. C3H6 is the molecular formula of propene. So here you can see the one bond is indicated by sigma and another bond is pi bond. So pi bond is less stable than sigma bond, so it can break easily. So we can convert this unsaturated hydrocarbon to saturated hydrocarbon by breaking the pi bond. So I'm gonna show you another example, that is butene, BUTENE, butene. So general formula of butene, similarly CnH2n, everybody. So C4H, 2 into 4, how much? C4H8. So draw the structure like this, 1, 2, 3, 4. Anywhere you can give double bond, whether here or here, double bond, and like this, 1, 2, 3, 4. Similar 1, 2, 3, 3, 4. Okay, for this one, 1, 2, 3, 4. For this one also 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, count the hydrogen. 1, 2, 3, 4, 5, 6, okay, 7 and 8. This is the structure of butene. So here is a double bond between two carbon atoms. So butene comes under the alkene, and alkenes again comes under the unsaturated hydrocarbons. So we can convert this unsaturated hydrocarbon into saturated one by breaking pi bond like this. So one thing remember, one thing figure out please, we can add hydrogen here by breaking pi bond. So we can convert unsaturated hydrocarbon to saturated hydrocarbons by breaking pi bond. Means we can add more hydrogen into unsaturated hydrocarbons. Similarly, let's see in the another example. For the unsaturated hydrocarbons, there should be double or triple bond. Means another example, series of alkyne. All the series of alkynes also comes under an example of unsaturated hydrocarbons. Number first, let's see in ethane. General formula, first of all we have to know the general formula of alkyne is CnH2n minus 2. CnH2n minus 2. So in ethane there is two carbon atom, and you can do like this, 2 into 2 minus 2, how much? C2H, 2 to the 4 minus 2, 2C2H2 for the structure, STREUCTURE structure. There should be triple bond between two carbon atom in alkyne. So you can write like this, 1 2 3 triple bond, and here is one covalent bond with hydrogen. So C2H2 is the structure of ethane. Similarly, you can do another example, propane, PYNE, propane yourself. So another heading is difference, DIFFERENC, difference between saturated, 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 and SATURATED, unsaturated hydrocarbon. So this one is your another heading, difference between saturated and unsaturated hydrocarbons. Here is saturated, SATURATED, saturated hydrocarbon on unsaturated hydrocarbon. So you can write here, there is single bond, single covalent bond between carbon and carbon atom. Similarly, there is double or triple bond between carbon and carbon atom. So here is single bond between two carbon atom like this, but here like this, or 1 2 3 triple bond. So in unsaturated hydrocarbon there is double or triple bond between two carbon atom, but here is single bond between two carbon atom, and these saturated hydrocarbons are stable hydrocarbon. These are QUIT, quite stable. These are less stable. These are less stable than saturated hydrocarbon, and we can't add more hydrogen, but we can add more hydrogen, okay, here oh my god, so difficult to write here, HYDROGEN, hydrogen. We can add more hydrogen in the structure of unsaturated hydrocarbons. So everybody, this one is very simple difference between saturated and unsaturated hydrocarbons. I think you can now get how the difference between saturated and unsaturated hydrocarbons. So everybody, go through the another heading. Another heading, please. So everybody, what is alkane and alkyne? Alkane and alkyne. So everybody, what is the difference between alkene and alkyne? Do partition your copy and write like this. So number first, the general, GENERAL, the general formula of alkane is CnH2n plus 2. Similarly, the general, GENERAL, general formula, FORMULA, formula of alkene is CnH2n, just only CnH2n. Similarly, the general, GENERAL, general formula of alkyne is CnH2n minus 2. So these are the general formula of alkane and alkyne. Similarly, in number 2, this all the alkanes comes under saturated. These are saturated, SATURATED, saturated. These are unsaturated, unsaturated. Similarly, these are also unsaturated. These are also, these two are unsaturated and this one is saturated. Similarly, there is single bond between carbon and carbon atom. There is single bond between carbon and carbon, but here there is double bond double bond between carbon and carbon and carbon atom. Similarly, there is triple bond between carbon and carbon atom. So here is double bond between carbon and carbon. Here there is triple bond between carbon and carbon, but here is just only the single bond between any two carbon atom. So you can represent like this. Here is single bond between carbon and carbon like this. This one are the saturated. Similarly, here is double bond like this. You can write like this. And similarly, here is triple bond. You can see here 1, 2, 1, 2, 3 bond like this. So these are the simple difference between alkane, alkene and alkyne. So another heading is homologous homologous SERIES series. So this one is very important for you. Actually, what is homologous series? So how we describe this one? You can figure out the name of these topics here. Homo means same type of any compounds. Means hetero means different and homo means same. So same type of compound comes under same general formula, or they comes under the same pattern. It's called homologous, and all the compounds come under the same series. It's called homologous series. So you can define here the series of similarly constituted compounds having same formula, same general formula, but two successive members are differ by CH2 group in their structure, or you can say in their formula. It's called homologous SERIES homologous series. For example, series of alkane. So again, general formula of alkane CnH2n+2, and the first member of alkane is methane in number 1, methane, methane. So okay, I will write here. Everybody see here, number 1 methane, methane. So general formula CnH2n+2. You can write the molecular formula C4H, sorry, not C4, C meth means 1 CH4, CH4. Similarly, in number 2, ethane, ETHANE, ethane. So what is the molecular formula of ethane? C2H, 2 into 2, 2 to the 4 plus 2 6, C2H6. Similarly, in the contracted form, CH4, you can write this one CH3, CH3, C2H6. Similarly, in propane, 1 2 3, propane, C3H, C3H8. You can share C3H. How much? 3 to the 6 plus 2, 8, C3H8. You can write in contracted form or condensed form, CH3, CH2 and CH3 again, 3 3 6 plus 2, C3H8, C3H8. Okay, this is the contracted formula of propane. And you can see here is the difference in CH2 groups, but all the members of these alkanes comes under same general formula. So all the compounds are derived by the same general formula, but they are different each other by CH2 group. Okay, in this way you can draw another example yourself, everybody. So let's see in the another example. Let's take the series of alcohols, series of alcohol. So the general formula of alcohol is CnH2n plus 1OH. This is the general formula of OH. So you can write in first one, methane, METHANE, methane. The general formula of methane is CnH2n plus 2. So you can get CH4 here for the molecular formula of methane, and if you remove one hydrogen atom, then you can get CH3 methyl radicals, and if you add OH for the alcohol, then it will change to CH3OH. This one is an example of alcohol. This is methanol. Similarly, another one, ETHANE, ethane. So the formula is C2H6, and if we remove the one hydrogen, similarly, then you can get C2H5 plus OH for the alcohol, and you can write CH3, CH2OH. This one is ethanol. Same ways for the propanol, you can write CH3, CH2, CH2 and OH for the propanol, and similarly for the butanol, CH3, CH2, CH2, again CH2 and OH. This one is the butanol. So everybody, let's see here. These all are the series of alcohol: methanol, ethanol, propanol and butanol, and you can derive the same ways by using the same general formula CnH2n plus 1 OH. So all the series of alcohols comes under the same general formula, but they are differ to each other by simple CH2 group. You can see here Here is only 2 carbon atom, but here is 3 carbon atom. So these are different to each other by the CH2 groups. So these series of alcohol can illustrate the homologous series. Now we come to reach the another very interesting topics, that is alkyl, 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 GROUP group, alkyl group. Okay, these alkyl groups are very simple. It is nothing but the hydrocarbon which is obtained by the removal of one hydrogen from the alkane. So the group 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 or hydrocarbon, the group or hydrocarbon which is derived by the removal of one hydrogen from alkane is called alkyl group. So the group or the hydrocarbon which is derived by the removal of one hydrogen from the corresponding alkane are called alkyl groups. Let's see the example from the methane, methane, methane again. So the molecular formula of methane is CH4, and let's remove the one hydrogen, so you can get CH3 radical. This is the methyl radical, methyl, methyl, an example of alkyl group, alkyl radicals. And another one, ethane, okay, ethane, ethane. So formula is C2H6, and if we remove one hydrogen here, then you can get C2H5 plus. This one is the ethyl. Similarly, from the propane, 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 formula is C3H8, and by the removal of one hydrogen, then we get C3H7. This one is the propyl. So these all are the alkyl groups. So you can say the alkyl radicals. So all the alkyl radicals can be obtained by the removal of one hydrogen from the proper alkane. Methane, ethane, propane, same way you can derive the another alkyl group from this series, propane, butane, and so on. So we can write the name of alkyl group by replacing here ANE by YL. So replacement of ANE by YL, and all the alkyl group can be represented by capital R. So all the alkyl groups, alkyl radicals are indicated by R. R indicated all the series of alkyl group. If we add this alkyl group with functional group, then we can get the proper compounds. For example, let's see here. So R, if bonded with OH, then these radicals convert to alcohol. So let's take the example of methanol. CH3 is bonded with OH to form methyl alcohol. Similarly for ethyl alcohol, C2H5 and OH, C2H5 and OH. So our OH is the functional group. This OH is the functional group. This is all about the alkyl groups. And one thing please, I'm going to show you that the general formula of alkyl, ALKYL, alkyl group, GROP group is just only CnH2n plus 1. CnH2n plus 1. So see here, CnH2n plus 1. Okay. For the methyl radical, C1H2 into 1 plus 1. Then you can get CH3 here. 2 1s are 2 plus 1, 3. Similarly, for ethyl radical, for this one, you can get C2 here, C2 and H2 plus 1. So C2H5, C2H5, like this, C2H5. So positive charge is due to the removal of hydrogen atom. Another main topics now, last one I think, it is functional, FUNCTIONL, functional group. Everybody, actually what is mean by functional groups, how it works in the structure of any hydrocarbons. So actually functional groups are the atoms or somewhere group of atom which determine the characteristics of the particular hydrocarbons. So you can define this one, functional, the functional, FUNCTIONL, the functional group can be described as an atom or group of atom which determine the characteristics, which determine the characteristics, CTERISTICS, which determine the characteristics of the compound, POUNDS compounds. Okay, just only compound. So functional group can be defined as the functional group can be described as an atom or group of atom which determine the characteristics of the compound, any particular compounds. If there is any other group with hydrogen or other than the hydrogen with carbon, then that atom or group of atom determine the characteristics of that particular compounds. For example, CH3OH is an example of alcohol. This one is the methanol, and CH3CH2OH is another members of alcohol, that is ethanol. You can see here this OH hydroxy group, you can say the hydroxyl also. This hydroxy group determine the characteristics of these compounds. So the presence of OH makes it alcohol. Similarly, another example, CH3OCH3. This one is the ether. Because of the presence of this oxygen group between two alkyl groups, so there is a difference in the functional group, this O and OH, so oxy linkage here, so it makes it ether. This one is dimethyl, methyl ether, dimethyl ether. So there is difference in functional groups, and the characteristics also different to these two one. These are alcohols and this is ethers, so they are different to each other. So let's list some examples of functional groups. So everybody do the partition of your copy and write down here. Here is name of okay, you can write like this. Here is functional, FUNCTION, functional group, and here is name of that functional group, and here is CORRESPONDING, corresponding CLASS class, corresponding class. In number 1, first OH, the name of this is hydroxy or hydroxyl, you can say hydroxy or hydroxyl, and corresponding class is alcohol, ALCOHOL. The presence of OH makes alcohols to all the hydrocarbon. Similarly, this X stands for fluorine, chlorine, bromine or iodine. These all are the members of halogen. We can say the halogen group. The name of this functional group is halo. If for the chlorine, chloro, for bromine, bromo, fluoro, iodo, and this comes under halogen group. Similarly, you can write NO2 here, bond NO2. This one is nitro, okay, here nitro compound. Similarly, C double bond OH, the name of this one is FORMYL, formyl. Okay, aldehyde, you can say aldehyde. This one is aldehyde. Similarly, this functional group is a keto. You can write here KETONE, ketone, for the corresponding class. Similarly, hydroxy, halo, nitro, and formyl, keto, and let's say 1, 2, 3. This one is a cyano, 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 CYANIDES, cyanides. And let's see here OXY, oxygen, oxy linkage. This one comes from ether, 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 for the oxy linkage. You can say methoxy, ethoxy, in this way. So this one is the very simple but important examples of functional group, and we will discuss the functional group thoroughly in the nomenclature of organic compounds in the next video. So only this much for today. If you like this video, please share to your friend, do subscribe and follow my channel Chemistry and Conscience, and press the bell icon so all the notification will comes you. Thank you all.